Okay, so everyone is on this massive hunt for clean energy. And, affordable green hydrogen is pretty much the holy grail. But what if you could make it with just sunlight and water? What if you could cut out the biggest cost, electricity, entirely? Let's dive into a potential game changer coming out of South Australia. So here's how we're going to break this all down. First up, we'll get into the main problem that's been holding green hydrogen back for so long. Then we'll look at this incredible new solution and a huge breakthrough it just hit. We're also going to get into the mind-bending science behind how it all works. And finally, we'll take a really honest look at the challenges and the potential ahead. All right, first things first, let's get right to the heart of it. Why is green hydrogen still so darn expensive? Because, to really get why this new technology is such a big deal, we've got to understand the massive problem that everyone in the clean energy world is trying to solve. I mean, make no mistake. You've got governments, huge corporations, entire industries. They're all betting big on green hydrogen. They see it as a critical piece of our clean energy future, right? A fuel that could power everything from trucks to factories. But there's always a but, isn't there? There's a big catch. And this is the big roadblock. The standard way we make green hydrogen today is through a process called electrolysis. Basically, you take a whole lot of electricity, hopefully from renewables like solar or wind, and use it to split water. The problem? Man, it takes a ton of power and these really expensive machines called electrolyzers, and all of that just sends the cost through the roof. So when you boil it all down, you're looking at two totally different ways of thinking about this. On one hand, you have the conventional route. It's this two-step dance of generating renewable electricity, then using that power to make hydrogen. But on the other hand, you have what Sparc Hydrogen is trying to do, which is basically skip that whole electricity middleman step and use sunlight directly to make the fuel. It's a fundamental shift. Okay, so this begs the question, right? How in the world are they trying to pull this off? Let's zoom in on Sparc Hydrogen and their pretty radical new approach. And there you have it. This isn't just some drawing on a whiteboard or a theory in a lab. This is the real deal. It's their actual pilot facility, and it's up and running right now at the University of Adelaide. This is where the rubber really meets the road for this new idea. So who are the players here? Well, this isn't some garage project. You've got heavy hitters like the mining giant Fortescue backing this, so it's a very serious effort. And their goal? To unlock a low-cost, decentralized way to produce green hydrogen. Just think about that for a second. That means you could make fuel right where you need it, say at a remote mine or farm, without ever having to connect to a massive power grid. So we've got the problem, and we've got this fascinating solution. But this is where the story gets really good. The reason we're talking about this today is because this little pilot plant has just hit a huge, and I mean huge, milestone. And you don't have to take my word for it. Just listen to Sparc's managing director, Nick O'Loughlin. He calls it a significant milestone, not just for his company, but for the entire industry. Whoa. When you hear language like that, you know something big is happening. So here's the bottom line. After more than a year of grinding it out, this facility isn't a what-if anymore. It is now consistently, day in and day out, producing hydrogen using nothing but direct sunlight. This is it. This is the proof of concept they've been working toward. But hey, this is just step one, right? The work is far from over. Now the real fun begins. The team is basically stress testing the whole system. They're checking for durability, for efficiency, and seeing how it holds up under all sorts of real-world conditions, like cloudy days, hot days, you name it. This all sounds amazing, almost like science fiction. But how does it actually work? Like, what's the science here? Let's pull back the curtain and talk about a process called photocatalysis. It's a fancy name, but it's basically a way of splitting water with just the sun. Yeah, so the official term is photocatalytic water splitting. But honestly, the easiest way to think about it is, well, it's like an artificial leaf. You know how plants use photosynthesis to turn sunlight into chemical energy? This is kind of the same idea. It uses that solar energy to literally crack open water molecules into their two parts, hydrogen and oxygen. It really boils down to three pretty simple steps. Step 1, sunlight shines on this special powder-like material called a photocatalyst. Step 2, that sunlight supercharges the catalyst, giving it the juice it needs to rip water molecules apart. And boom, step 3, the hydrogen gas is collected and you've got clean fuel. Simple as that. So you might be asking, what is this special powder? What's the secret sauce here? Well, it's a super advanced photocatalyst that actually comes from their partners over at Japan's Shinshu University, which, Just goes to show you that this kind of cutting-edge innovation is a truly global effort. All right, so we've seen the incredible breakthrough, we've peeked under the hood at the science. But what happens now? It's time for a little reality check. Let's take a balanced, honest look at the road ahead, the massive potential versus the very real challenges that are still out there. I mean, look, the potential here is just off the charts. We're talking about a system that's scalable, that can be put anywhere, that could be dirt cheap, and doesn't need a massive power grid. That's a game changer. But, and this is a big but, the hurdles are no joke. Scientists still have to figure out how to make it last for years and years, because that catalyst can break down over time. And they've got to nail the process of separating the gases to make sure the hydrogen is super pure. So where does that leave us? Look, this is a huge leap forward for a technology with incredible promise, but there are still some serious mountains to climb on the engineering side before it's ready for prime time. So the big question remains, is this the breakthrough? Is this the tech that finally unlocks cheap, abundant green hydrogen for all of us, everywhere? Well, the race is definitely on, and you can bet the entire world is watching to see what happens next.